Finally, we're going to get to the meat and potatoes and gravy of this project, which is the game view controller, where everything takes place. Now let's get into it.
Xcode. Import scene kit. Import Cocoa.
So we import scene kit,
Import AV Foundation.
Cocoa AV Foundation,
Import Quartz Core.
and we're going to import Quartz Core. Quartz Core, so Quartz is CPUs actually use crystals to actually create a clock. And each of these clocks have frequencies. That's why you have gigahertz, megahertz, and so on. And the hertz is the number of times per second you can have operations. So 2.3 gigahertz, meaning that you can have theoretically 2.3 billion operations per second. And if you have a 4-core, that would make 9.2 billion operations per second, which is pretty cool. It becomes a bit overwhelming to think about, but this is pretty much how it works, and this is used to actually get the current time inside the clock. And I'll explain where we're going to use it.
New line. Enum arrow colon UI and T16 left brace.
So we still got the arrows.
Case down equals 100. Case up equal case left. Case right equal space. Var vector colon flow to left brace. Switch self. Case right brace. Right brace. New line.
So this is the enum we've been using all along with all the other podcasts.
Class game view control.
So I don't think it bears it requires explanation.
New line. Class game view controller colon and S view controller.
And it's a game view controller, part of the NS view controller superclass.
SCN scene renderer delegate left brace.
And we make sure to have the SCN scene rendered or delegate protocol delegate, so that we can actually capture all of the frames of the 3D simulation running.
Var direction equals flow to left parent 0, 0 right parent.
So direction is flow200. This we've been using before.
Left camera node equals SCN node left parent right parent.
Camera
At IB outlet we var game view colon game view.
Game views as an IB outlet. Sorry.
Space. Left scene equals SCN scene left parent right parent.
The scene
/ non-dynamic nodes.
the non-dynamic nodes.
Left comic equals SCN node left parent right parent.
So the comic is basically just So it's the comic itself. Will constantly be calling it out to do things. That's why we actually need it.
Left bar equals SCN node left parent right parent.
And the bar is just going to be static, and we're just going to be adding some some sounds to it.
Space / audio engine component. Var engine colon AV audio engine.
So we got the AV audio engine and the environment node.
Var environment colon AV audio environment node. Left distortion equals AV audio unit distortion left parent right parent. Space.
So here I got a distortion. What I was planning on doing is actually adding a distortion filter on top of the project, so that at some point you can actually turn it into something like of a radio signal of the comic show. It will probably be inside the last build, or it might come into a different podcast, but for now we're not using it.
Space new line. Override func awake from mid left parent right parent left brace.
So here we got the awake from nib function when it actually calls out the XIB file, and all the interfaces and everything are inside there. The game view is inside there. Once that is loaded up, this is where the sequence of loading things starts.
Space vars environment equals false left brace. Space override func new line.
So I'm going to unfold this.
Unfold methods and functions.
There.
Over super dot space / start loading assets.
So now we're going to call it the load assets. The load file sources.
Load sources left parent right parent.
Load sources. Boom. It takes all of the different files inside the folders.
Current comic equals comic names left bracket 1 right bracket.
So current comic is comic names, and here you can choose which comic you want at the beginning. You'd have to know what the index is. In this case, I set the index of 1, which is the second comic.
Comic index equals 1.
And comic index equals 1. If I wanted the first one, then comic name would be comic names, and the subscript 0, and the index for this one, comic index, will be 0.
Space / create and add a camera to the scene.
So we add the camera.
Camera node dot name scene dot root space / place the camera. Camera node dot position equals 0.0 right parent space.
And these things we know already.
/ place on dynamic nodes.
Now the non-dynamic nodes. So we got the comic and we got the bar. We'll attach a name to them just to be nice.
Scene dot root node dot add child node comic. Scene dot root node dot add child node bar.
So we add these two together.
Comic dot position equals offstage.
And comic dot position is offstage. Offstage is a variable that I have, which is SCN vector 3. That's some point a bit like forward and towards the right, and you want them to actually walk or wheelchair towards the actual mic stand. and off stage is a value that I will need when the comic needs to get back out of the stage. That's why I set up a variable for it. I like things to stay that way, and it's good practice anyway. You don't want any quote unquote magic numbers inside your code, because then they will be hard to retrieve or to find, and you know exactly where all of your variables are.
Comic.name equals quote comic quote. Bar.position equals SCN vector 3 left parent X colon dash 15.0 Y colon 0.0 Z colon 5 point bar.name equals quote bar quote.
Now bar, it's, I set up something over, towards the left. Now this is, yes, I know I just spoke to you about magic numbers and I just placed one, but it's just in this project I'm just putting it there because I don't really think I need to try to fiddle around with the position of the bar. I just know that I want it on the left.
Left center node equals SCN node left parent right parent.
Now center node, this is where the fun starts, because we're going to start generating tables, and the center node is the center table, and we want to automatically generate these tables and specify how many number of guests per table there are, and yeah.
Center node dot name equals quote center quote.
So here we just give it a name.
Left node equals SCN node left parent right parent. Left node dot name equals quote left quote. Left node 2 equals SCN node left parent right parent. Left node 2 dot name equals left right node equals SCN node right node dot name. Left right node 2 equals SCN node left parent right parent. Right node 2. Left back node equals SCN node left parent right parent. Back node dot name equals scene dot root node dot child node center node.
So now I'm adding all of these different ones, center, left one, or left 2, right 2, and back. So I basically have 6 tables.
Scene dot root node dot child node left node 2. Scene dot root node dot child node left node.
And I add them all to the scene's root node.
Scene dot root new line. Center node dot position equals SCN vector 3 left parent X colon 0.0 Y colon 0.0 Z colon dash 5.0 right parent.
And here I assign positions to all of these 6 different tables.
Left node dot position equals 0.0 left node 2 dash 15 right node 10.0 right node 2 dot SCN vector 0.0 back node dot SCN vector Y colon 0 space create tables left parent node.
Okay.
Space.
Now here I've assigned a utility function, which is called create tables.
Create tables left parent node colon center node guest colon 5 table diameter colon 2.0 right parent.
So there are 3 arguments inside this function. So the node in which I want to actually start generating the guest chairs and the guests themselves, and then the number of guests, and then the diameter of the table.
Create tables left parent node colon center node guest colon 5 table diameter colon 2.0 right parent.
And I'm going to do this with all of the 6 tables.
Create tables left parent node colon left node guest colon 5 table diameter colon 2.0 right parent. Create tables left parent node colon left node 2 guest colon 5 table diameter colon 2.0 right parent. Create tables left table diameter create table guest colon create table back node table diameter space.
Now I've created all these tables.
Space / set the scene to the view.
Now we're going to set that scene to the view so the simulation can start running.
Self.game space self.game view hang.scene equals scene space / allows the user to manipulate the camera. Self.game view hang allows camera control equals true.
Okay, so this is again for debugging, and we can put statistics and so on.
Game view dot is playing equals true. Space.
Now game view dot playing equals true. Boom, simulation starts.
Engine equals game view dot audio engine.
And engine equals game view dot audio engine, because that's the variable, that's the engine that we want for the audio layer in case we want to put filters and so on.
Space / start the ambient sounds.
Now, start the ambient sounds.
Left crowd 1 equals SCN node left parent right parent.
Now, crowd 1 is a node, so we just kind of start to put some crowd inside the actual scene.
Left crowd 2 equals SCN node left parent right parent. Scene dot root node dot child node crowd 1. Scene dot root node dot child node crowd 2. Crowd 1 dot position equals SCN vector 3 left.
So the position
dash 2.0 crowd 2 dot position equal 2.0 right crowd 1 player equals SCN audio player left parent source colon crowds left bracket 0 right parent.
Okay, so we just got, in this case, we only have 2 crowd files, but if you want to put many more, put a stadium or whatever, you can. But in my case, I just have 2 crowd, and that's actually more than enough. It creates a good amount of richness into the ambience.
Crowd 2 player equals SCN audio player left parent source colon crowds left bracket 1 right parent.
So these are 2 SCN audio players, and I've got them statically declared a bit later down inside this file.
Space crowd 1 player dot audio source hang dot loops equals true.
And I want the audio source to actually loop because it's just an ambient sound.
Crowd 2 player dot audio source hang dot loops equals true.
Although these are actually positional.
Crowd 1 dot add audio player left parent crowd 1 player right parent.
There you go. Crowd 1 add audio player.
Crowd 2 dot add audio player left parent crowd 2 player right parent new line right brace. Space.
And that's it. The awake from nib is pretty much all we need.
Var is environment equals false. Left brace.
Now, var is environment equals false.
Did set. Left brace.
If environment is true,
If is environment. Left brace. Wire system. Left parent. Right parent.
then we wire the system.
Right brace. Right brace. Right brace.
This we used in the previous tutorial.
Var mixer colon. AV audio mixer node.
So here we got the mixer. And from here, this is where we got the SCNC renderer update at time function. And there are quite a few variables in there that I will require.
Var last joke time colon. Float 64 equals 0.0.
So last joke time. And so float 64, that's when the last joke actually came about. And this is in float 64, that's in pure time.
Var capture joke time equals false.
Capture joke time, that means that when a joke starts, we start capturing the time in time t. That means it's not the time of the joke itself, but it's the timeline of the renderer itself from when it started.
Var start time equals CA current media time. Left parent. Right parent.
Var start time is CA current media time.
Var clap start time equals CA current media time. Left parent. Right parent.
Clap start time is CA current media time.
Var started equals true.
Started equals true, like the simulation starts immediately as we run it.
Var moving equals false.
Moving equals false. That's to say whether the actual comic is moving to go towards the mic stand.
Var reach mic equals false.
Reached mic to say whether the actual comic has reached the mic. These are all Boolean values because these are all states.
Var reach off stage equals false.
Reached off stage, that means if it's reached the outside of the stage when the comic goes back.
Let off stage equals SCN vector 3 left parent x colon 20.0 y colon 0.0 z colon dash 20.0 right parent.
Okay, so the off stage has a position of so x is 20, so like kind of 20 paces towards the right and 20 paces towards the front.
Let mic pose equals SCN vector 3 left parent x colon 0.0 y colon 0.0 z colon dash 35.0 right parent.
Okay, and then the mic position is actually kind of center, and it's trying to go like towards center as in x, and it's like 35 paces in front.
Var last move time equals CA current media time. Left parent. Right parent.
And last move time is CA current media time.
Var delta colon CG float equals 0.033.
And delta 0.033. That's a pretty good number.
Var speed colon CG float equals 1.2.
And the speed is 1.2. So what I would have in the simulation is speed time delta. That is the distance again per step, and that's per frame inside the renderer.
Var poked mic equals false.
Poked mic. So like once the guy with the cane or the guy on the wheelchair pokes the mic because he bumps into it, whether it has poked it or not.
Func renderer left parent underline renderer.
So what I'm going to do, I'm going to just kind of skip the renderer first because that's where all the states are happening.
Full methods.
And that's where we need to tell it whether it's going to joke, whether it's going to applause, whether the crowd's going to laugh, whether the comic is starting its introduction, and so on.
Update at time colon time interval right parent space.
I told you this one was long, but it's well worth the patience.
Func renderer left parent underline. Dead render scene time interval / space. Func swap comic left parent right parent space.
Okay. Now, the first function we're going to create is func swap comic.
Unfold. Func swap comic left parent right parent left brace.
What we're doing when we swap comics is that the whole simulation, that means the comic going, introducing himself, joking, and then going back has been completed. So we kind of reset everything to 0 or false.
Is leaving equals false.
So is leaving equals false.
Intro finish equals false.
Intro finish equals false.
Comic index equals left parent. Comic index plus 1 right parent percent comics dot count. Current comic equals comic names. Comic index equals left.
And here what we're doing was we're swapping the comic.
Intro comic index equals left parent. Comic index plus 1 right parent percent comics dot count.
Now, comic index plus 1 percent comics dot count. We're using modular arithmetics. So the comic index, if it starts at say 0, so that's like in the 2-dimensional array for the jokes, intros, and outros and moves. Well, that's the first array, right? And we want to add a 1 to it, and so it goes to the next one. But then there's a count of the number of comics inside the array itself. And what we want to do is use modular arithmetics so that if, say, for instance, in this case, we have 2 comics, then we start at 0, then the next one's going to be 1, and there's no 2 because there are only two arrays inside the comics array. That's why if it reaches 2, it goes back to 0. And that's why we use the percent or modulus operator, which is often neglected, but is very useful.
Current comic equals comic names, left bracket, comic index, right bracket.
And now...
Current comic equals comic names, left bracket, comic index, right bracket.
And the current comic, which is a string, and it takes it from the comic names with the...
Comic index equals left, current comic index, current comic equals comic names, left bracket, comic index, right bracket.
Comic index, which has changed.
Crowd laughing equals false.
And crowd laughing equals false.
Crowd clapping equals false.
Crowd is not laughing or clapping or anything.
Delay left parent 2.0, right parent left brace.
And we just wait a couple of seconds before the next guy comes in.
Self.started equals true.
And self.start equals true, which means that the simulation will start.
Self.reached mic equals false.
And it has not reached mic.
Self.poked mic equals false. Self.joke count equals 0.
And the joke count equals 0.
Self.current joke equals 0.
And current joke equals 0. So we're pretty much resetting everything.
Right brace, space, var crowd equals left bracket SCN node right space.